proceed. Settle down, please. I forgot Mr. Felix will not be coming around today, so I will finish the physics and I will finish the chemistry. Then we can go. Okay, you thought I just wanted to do physics. I'll finish the physics and I'll finish the chemistry. We don't have much to do again in the chemistry and physics. So I'll quickly finish the physics now. Then I'll do the chemistry. But before then, please, there are 4 of you that I said you should help me get money for JP and Pepe. Has everybody giving you money? Please. The last time I talked to you, I think I begged you. I said please. That you should help me give them. They have paid their school fees. They have resumed to school. They are not begging us for money. But it does not mean that that money will not still go a long way to help them. And that's one of the things I was saying in the morning. That when people help your life, you to reciprocate. Show your heart of gratitude. But many of you, just to help at a point, you find it hard. And if you help, you will also receive help. I've always told you one thing. Be the type that learns to give, not the type that learns to take from people. Even though you are broke, you are broker than the broke. Even though you are poor and someone is rich beside you, have this mentality of even though the person is rich, you still want to help the person. Not depending on that person. Like indirectly, you want to help the person. Not because the person is begging you. Even the rich needs help. There are sometimes that you might just need to be there. There is this act of kindness. There is a friend of yours in the hostel that is probably rich, have money, and you don't have much. But you cook at the time and you look at the person and say, oh, I made this amala. Take a part of this amala and eat it. Not because the person is begging you. Someone like me now, I like it. Growing up, I love cooking for people to eat. So it was a part of me. All my friends were richer than me. All my friends. But then I'll go to town when I go to teach. As I'm coming back to the hostel or to the room, I'll buy foodstuffs. I'll buy a pussy, buy everything. Then I'll get to the room, I'll make a pussy, make semo, and all my guys will come, carry their plates, and I'll serve them. I was used to that thing, and I love it. I will enter the kitchen, boil turkey, fry stew, make rice. And I'll make rice, and all my friends will come, and I'll serve them. And at the end of the day, when they are not eating, I will still pack all the plates. Because I don't like anywhere dirty too. I don't like it being dirty. It's just maybe the way I grew up with my grandma. So it's one of the things my grandma does. One of the things my grandma used to tell us if we cook is that we should cook visitor zone. Either we are expecting visitor or we are not expecting visitor, we must cook visitor zone. So we are always cooking in such a way that if you are coming, we will not keep the food under the chair. That's how she trained us. So when I go to campus, I'm always cooking like I have people around me that must also eat. And some people might take you for a fool, but you don't worry. Just keep minutes, and you will now see how all of these things will come back to you. So please, indirectly, what puts me to where I am today is the grace of God and grace of men that God has given me. All these guys that you feel like, oh, I used to feed them. I have one of them that I promise you, even the mom will still talk, maybe last week. Every time, every weekend, the mommy will bring soup from Ibadan to Ife. That means he's not poor. Anytime he needs money, they will give him. Anytime. And that weekend, not do my gentle. So, but now, he's in US now. When I wanted to start primaries, it was when we were living together first in this place, Akobo, in the same house, the same room, different rooms but the same flat, 2-bedroom flat. So, and when I wake up, I'll go to market. See, he does not like all those stuffs. I'll go to market, I'll buy food stuff, I'll cook, I'll serve him when he's working on his own system. And I'll carry those plates again. We're living together, we're happy. Now we even come and teach in town. He was doing online work because he was working for some companies abroad. And they pay him like 160,000 per week. That was before COVID. On his birthday, they gave him break and they still paid him for that week. It's nice, just like two beds in the room. Then I put curtain in all of the rooms. I'm not sure I still have the picture of that hostel again. Then, if you check the hostel, you see it's online. So if you go and check online, you see those pictures. I already got better. Chico said he would bring AC for me from Abuja that time. But transportation was the problem. We already had meters at the classroom to have AC. That was the mindset even when we just started. So you say I should do AC now, you now think to now move me. I'll do it now if I have the money. But this one I could not do it because it was going to cost me around 15 million. And I did not really plan it. So eventually that place started like that before students now came. First set one tí lóṣù méjì wọ́n ti kọ́kọ́ ya gbogbo carpet àgbọn gbogbo kọ́tì yàrá yẹn ó ti di Nigerians. People don't deserve so many things. That's the thing. As much as people want the best for you, you yourself, you don't want the best for yourself. You don't want it. Go and look at all those places they renovated in where you now. AC everywhere, chairs. But you see students, some people will even stand on that. And they know it will break, but they will stand on it. They know. Part one, we want to enter classroom because we want to sit at the front. They will not be, and they make all the entrance with glass. They will not be pushing themselves. Some people go from the back, someone will climb chair, just to come and sit at the front. They will break all the glass at the entrance just to sit at the front for chemistry. And upon all their fights, I will allow everybody to enter. I'll just enter. I'll just come forward. Please, can you please help me to shit? You see that all the fight they were fighting, what is that they want, the more fight no one want to. Because what I change seats, the whole seats, no one. I mean, I'll tell maybe it's five that are sitting here. Please, I'll manage. Please. My dad have a better control. My dad she class me, my dad. So there are so many things that when you do your life, it helps you. Learn to give. So don't be stingy. Don't be like this every time. It is bring. And I could remember all this period. I told you, maybe it was last year, there was one of our friends in the class. One of them, number one, when he wanted to do his wedding, he invited all of us. Everybody left the group. Nobody attended his wedding because of his attitude on campus. I was the only one that still attended. They needed me that reach it on like, I don't count things. As one that still attended. Then one created group, and we knew him when we were knowing you that used to be full of multi, he's so wasteful. And we knew him. So your friends know you. At the stage, he will play naira bet, he will do this, any small money like this. He's risking a lot, and he had opportunity. He even had car when we were doing. He had a car, he has a farm, but he was just wasting, lavishing the money and all. And at the end of the day, he now had problem. He created, had all of us wanted to tell us what he was going through. Everybody left because they've been warning him, they've been telling him. So God will help all of you. So please, 1K is not too much. Some of you are just stingy. 1K is not too much. The moment you start seeing that something is too much for you, your mentality will be, please, God will help you. So please, I'll give you till Monday. I'll give everybody till Monday. So please remind them. It's the money for JP and Pepe during the times they came to teach you and their impacts in primaries before they left. So please, give it. Then by Monday, they will collect it and they will give them. So when they give them, they can go and use it for whatever they want to use it for. So please don't forget that God will provide for you. You will not also beg. So you don't know how God will bless you too. So do your best. And they are not begging and they are not saying it is by force. But it is what we call acts of gratitude. We just try our best to return. So let's actually complete the thesis. Applications. First is, let's define electrical energy. Electrical energy and power. Electrical energy and power. Energy is defined as the work done in a circuit. Energy is defined as the work done in a circuit. Work done in a circuit. Why power? Please note the difference. So, as simple as that statement is, Jola will never allow us to forget. She will never allow us to forget. They asked her in UI post UTME to define, was it power or being energy or something? Okay, they defined, they said rate of doing work is what? Then she chose energy. So, and she came back, she wanted to kill everybody because she was so angry at herself how she missed that question. And I'm sure that until now she has not forgiven herself. Because I think it was that year that she didn't gain admission. Maybe that question would have been the one that would have left her that year. So as simple as it sounds, the work you do, we said energy is the capacity to do work. Energy is the ability to do work. So that work you do is what we call energy. So if I say electrical energy, I'm talking about the work that is done inside a circuit. Don't put that word rates. The moment you add rates to it, then it becomes power. The rate at which you now do the work is what we call power. You and I now can have equal energy. Let me put it that way. We can have equal energy. We are to carry a load from here to that place. We are going to do work using the energy in us to carry the load from here to that back. But now, the first person to reach there is the one that has the highest power. If I carry the load, then I get there in a short time before you, then I will be said to have power, not energy. I did that work in a short time. But if you do that same work in a longer time, then you have low power. If you are to carry 2 blocks or 3 or 2 blocks, I carried my own 2 blocks at once to the same distance and I dropped it. But you first carry one, you drop it. You carry second one, you drop it. You still did the same work, Abi. The same work I did is what you did. But the only thing is that the time I did it was different from the time you used to do it. So the power is the rate at which the work is done, or the rate at which you are using energy. The energy is being dissipated. So right, I said energy is the what? The work done in a cycle. While power is the rate at which the work is done in the cycles. The rate at which the work is done in the cycles, or the rate at which energy is dissipated. Can we, this person said, can we use energy without doing work? In physics, yes. In physics. As I am now, I'm using energy, but I'm not doing any work in physics. Do you know why? I'm not doing any work. Because as much as I'm not covering a distance, I'm not doing any work. So, go there, sorry. Control by that's your rod and energy is the ability. You can do the work. That's ability. That's your energy. You have the ability, yes. But are you doing it? It's a different statement. Your energy is just like can in English. Can. You have the ability. But will is now dependent. All of you can study, all of you can read, but you have the will to read. Is now the difference. So, I can carry a load and put it on my head. In physics, I'm not doing any work. I'm not doing any work. But if I'm lifting the load like this, I'm applying a force across a distance to put the load on my head, then I'm doing work. But the moment that load is on my head and I remain stationary, I'm no longer doing any work. So that's it. You can be expending energy and not do any work. Because many things are working inside you, so you are using energy. But in physics, you are not doing any work if you do not cover a distance. So you have done work, energy and power. So now, power, I said, or the rate at which what? Energy is dissipated. That is, energy is wasted in a cycle. Energy is either converted, given out, and all of those things. So power is equal to energy over time. The unit of energy is joule, Abi. The unit of time is what? Second. So the unit of power is joule per second. Or, simply put, watts. Watts. So, if you look at this one now, it might be maybe 600 watts. And this one might be rated 50 watts. Which one will consume our power faster between the fan and this bulb? The fan. In a short time, because of the rate at which this one is working, before you know it, you have consumed enough power. That's why if they want to install for you, they will do all those calculations and the rates at which you want to use them before they do it. So, rates at which you are consuming energy, time, is what we call power. And the unit is watts, then joule per second. Then, you remember, work from what you did in electrostatics. We said something like this, that electric potential is the work done in moving a unit charge. Abi? Meaning that work done is equal to QV. Do you remember? That means that I can bring this here. Work is the same thing as energy. So I can say power is equal to QV over T, right? This is another equation. You can relate them. There are a lot of formulas for power. And that's why most times when they ask you questions on power, they can say which one is true of power. They'll just put different formulas so for you to show them which one is not true. So now, you remember that we also said that Q is equal to IT. Abi? Meaning that I can be equal to what? Q over T. So if I bring Q over T here now, power becomes what? IV. So this is called electrical power, IV. So when you know the current flowing in the circuit and you know the voltage across the circuit, you can calculate the power. And another thing is that so from what we have here, you now remember that, please don't forget this one, it's important. You remember that V is equal to IR, Abi? So if I put this here, that formula becomes I square R. Power is equal to I square R. Are you there? Also, if I make I the subject of the formula, that means from V is equal to IR. So I can say I is equal to V over R. So if I bring that here, I'm going to have P is equal to V squared over R. That's another important formula. All these formulas apply to power. So they can list them and say which of the formula is not correct for power. There are things you can derive on your own if you get used to them. It's not so hard. So just get used to them. So quickly, let's talk about Joule's law of heating. Joule's law of electrical heating. So that heat that you always generate in most of your home appliances, iron, heater, phones, and all. So this is the law that guides the heat you generate. So now, Joule's law of electrical heating, before I define it, let's write out the formula. You know that E is equal to power times time. Abi? Power times time, that's energy. And power is equal to I square R. So I square RC. So energy. So this law now states that, so write this formula first. Are you here? Are you through the board? We are right, please. So we can now solve all the problems on electricity if you want to. I'll tell you the electric power transmission, which I've told you about before. But I'll talk about it quickly again. So you have box A from what the person is saying. So someone asked this question. What is the definition of work done? Work done is force multiplied by the parallel distance. I mean, work done in a particular direction. Work multiplied by parallel distance. I mean, force times distance. That is work done. But that distance is like displacement. And when you talk, you know there's difference between distance and displacement, Abi? So the person is now asking that if there's someone that moves this box from A to B, then the person moves it from B back to A. Has the person done any work? In physics, has he done any work? He did not do any work. The person has not done any work. He moved in the positive direction, is now moving in the negative direction. He did positive work, he now did negative work. So work cancel work. He has not done anything. That answers the question. We are not to. So, have you written this? Joe's law of eating states that Joe's law of eating states that the amount of heat energy dissipated in an appliance or a circuit, the amount of heat energy dissipated, DISSIPITED, dissipate, the amount of energy, heat energy dissipated in a circuit depends on the square of the currents flowing through the circuit, the square of the currents flowing through the circuit, comma, the resistance of the appliance, and the time of flow of the current. The square of the currents flowing through the circuit, the resistance of the appliance, and the time of flow of the current. E is equal to I square RT. That's the formula. So the heat you generate in the circuit, heat is a form of energy. So the heat generated is equal to, it depends on square of the currents, the resistance, and the time the current is flowing. So that's that. Next thing to quickly talk about is energy consumption. Energy consumption. Who gives us energy in Nigeria? In Ibadan, I think it's IBEDC, Ibadan Electricity Distribution Company. So now we use prepaid meter, but they are still billing us. So how do they bill us? Those days, they always bring a bill to your house. And that bill they bring to your house in a month contains the total amount of electricity you have used, you have consumed for that month. Then you will now pay them. Pay iye noti moti low, lele, and you pay them. So how would they do it? In your house, you know what you have. You have bulbs, you have fan, you have TV, you have everything. In a country that is okay, all these things you are using, there's a rate at which they consume electricity. Now, at the end of the month, they will help you calculate everything. So if you like, leave house in the morning, on your work down, your money is coming. Leave your TV on, leave everything on. They will come to your house at the end of the month and tell you the total energy you have consumed in that household, and you pay for it. But it's unfortunate that in Nigeria, either you have lights for 1 month, or you do not have lights for 1 month, they just come to your house. Pay 20,000 for Shuyi, enjoy about 3,000, I saw the 5. Tatomado. I remember then, when we just got to primary school, the Nepal official just come and just give us 20,000 naira. Pay not 30 loan. Tutorial and shaping, then because we're not so using the hostel. Tabati wala lo ati lo, ina tabalu in the month we over 1K. People that loan not 20K. Then when I got close to them, they will now say that ọ̀gá wa ni o, ọ̀gá wa kàn ní ká lọ pa 10 million wá lé ní. So táwa náà bá dẹ̀ ti bọ́ síta a máa pín kéré ní ìwọ 20k ìwọ 50k táwa ti rí ilé everywhere ṣe rí, then this is the amount you are paying. So it's not about what you use, it's about iye tó gbọ́dọ̀ wọlé lọ́jọ́ yẹn, by fire by force. So those we did not use light in my house for 1 month and you want to come and take money, we are in Nigeria. So what would they do in energy company? They measure it in power times time. This guy now has his power rating, the fan. They can say 1000 watts. This 100 watts. Maybe all these 100 watts. How many are we using? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 8, 9, 10, 11, 12. So all these 12 bulbs now, each of them is 100 watts, are they? So that makes 4,200 watts. Then let's say those ones are just like 500 watts. Everything shall 5,500 watts. So the total power, this one is now working too. Let's say this one is rated 1,000 watts too. For the 6,400 watts. You will add everything together. That's the power. They will now divide it by 1,000. That's to give you kilowatts hour. Now, how long did you use it? 1 month. They will help you calculate it. So the total of 1 month for those hours, how many hours are in a month? They will now tell you that 1 kilowatt hour costs 5 naira or 0.5 kobo. That's 0.5 kobo. When you now calculate all the ones you use and for the hours you use it, then you multiply by 0.5. That's the amount you will pay in a month. But that's not the case in Nigeria. Don't let NEPA come to your house and say, Mommy, I'm already working offices. I love that 20,000 báwo wá ṣẹ̀rù bẹ́ẹ̀ sọ owó sí primers lọ́fẹ̀ẹ́ ni because máa fojú wọn rí. So tó bá ti lọ bá wọn kò ṣe calculation dáadáa tó bá ti tiẹ̀ mọ́ pé ilé má sọ pé wá primers o. I'm only teaching you what you need to know when you get to a country that knows it. So your energy consumption is measured in kilowatts hour. Mistake people used to make here is that they used to say it's kilowatts per hour. It is kilowatts hour for the number of hours you use multiplied by the power. So, right. Electricity distribution companies measures energy consumed in kilowatts hour. So you now write E is equal to power times time. E is equal to power times time. Power is usually in kilowatts. Time is usually in hour. So the energy you use in your house is measured in power times time. Let us finish. So some questions on everything quickly. So now this is kilowatts, this is hour, and that's the unit. So they can ask you for the units of energy consumption. It is kilowatts hour. Don't say kilowatts per hour, because I still have someone say kilowatts per hour. People make that mistake. It is kilowatts hour, not kilowatts per hour. It is energy, kilowatts hour. So the next thing you now need to know is that don't sleep. We have what we call home appliances. So, what are appliances you have in the house? We call them home appliances. These are devices We will solve questions on everything. These are devices that consume electrical energy. These are devices that consume electrical energy using energy conversion methods. These are devices that consume electrical energy. So now, you see that iron consumes more because iron produce heat. And for iron to produce heat energy is H. It's going to depend on the square of the current flowing through the iron, the resistance of the iron, and the time at which you use the iron. So the heat generated in an iron, according to Joule's law of heat, is equal to I square RT. So now, most of these appliances, they used to have something called a plug. That plug is what you will plug to your socket, Abby, that you plug to sockets. And that plug used to have 3 mouths. Some have 2, but it's supposed to ideally have 3 mouths. Shake it. So now that plug has different wire. Those of you that have seen those wires inside before, there's a red wire, there's a black wire, there's a yellow or green, depending. So for your appliances, the plugs in appliances, there's a way they are connected. So there are wires you have and the functions of those wires. And let me say the color of the wire, so they can ask you. So when you check your appliance, there is a wire that is called a live wire. And they always tell you should not touch live wire. There is what is called a live wire. What is the function of live wire? From that power company, as electricity is entering your house, it is live wire that helps you bring electricity that comes into the house. So it brings in electricity from the source. Live wire brings in electricity from the source. That's the function. Is that taken? It brings electricity from the source when you plug it. So it has the live part, the neutral, and the the heads. It brings electricity from the source. What's usually the color of live wire? Red. It is either red or brown, not blue. It is either red or brown. Please don't forget. RB. It is red or brown. Then neutral wire. Neutral wire. Neutral wire returns the electricity to the source. You know, if you connect the circuits, it has to be complete. So ìkan ló máa gbé current wá, ìkan ló máa dá padà. Ṣé you get? So that's how it goes. But if you cut a part of that wire, it will not work again. So neutral wire returns electricity to the source. Ló máa dá padà. Are you there? So what are the colors of neutral wire? Black and white. Eh? Black and white. Òyìnbó àtàfin. It is blue. It is blue. It is blue or black. It is blue or black. Neutral is those life is red or brown. They ask this color. Neutral is blue or black. So the last one, it's the heads wire. You did electrostatics. And you know what earthing is. Earthing is to get rid of excess charge. The charge to poverty body. It will be helping you to take it out so that you don't feel electric shock in the house. So, earth, this helps to prevent electric shock. It helps to prevent electric shock or excessive flow of charges. So it's about to see that means so it helps to prevent electric shock or excessive flow of charges. Now, if neutral is not there, do you think your lights will work properly? It will not work. But if earth is not there, it will still work, Abi, because there's something bringing in, there's something taking it out. So what's the color for earth? It is green or yellow. So you can see any of this in your option. So how can you remember this? So I don't know how you remember this, but I'm just thinking about something that rates of beating guys blue-black. You can beat someone blue-black, Abi. It's corrected expressively. So the rates at which you beat guys blue-black. So rates is talking about red, beating is talking about brown, then guys green and yellow, then blue-black. You already know blue and black. You already know this one will be brown since you know blue black here. Do you get the point? So since you have blue black here, so you can't confuse this. You already know that will be brown. So that means that this one will be your life, this will be your X, and this will be your neutral. So you can just remember that with learn, so that you don't mix them up. So learn the rates of beating guys blue-black. So it follows everything like that. Oh yeah, come. This is like oh yeah, so the entrance of Primax. So Mori G. White wire, live wire, white wire, kilo shade. Are you asking a question? That have a white wire. They might just, sometimes they used to use some other these things to clip them. But the common ones you are supposed to have that shows you that, oh, this is life, like this. Is that taking? Sometimes they use some other, I've forgotten what they call that organic pipes that they use in electrical installation. We have done polymers now. So please, learn the rates of beating guys blue black. If you can remember that. That's what I can think of now for you, because I realized even I used to forget at times. So now I had to calm down, be processing it before I remember that it is that. What about when we bypass electricity in meters? What process does that undergo? Or bypass not the process for 2 million. So if you bypass, you tapped current where you are not supposed to. All these things too, they are tapping now. Tap here, tap here, tap here, tap here, so that everything work all together. So if you see a wire outside that current is flowing, you can peel it. When you peel it, o lo wire mo, wà dé fà lọ síbi tó ti fẹ́ náà, wà á ṣe yẹn náà síbẹ̀. So putting it there now, you have made it to be in parallel. So as electricity is coming, it will pass through your side, it will pass through this side, and they continue to do their work. But bypassing is a statement of offense in the law. So we going to bypass electricity, òfin máa mú yín lọ́jọ́ kan. Torí wọ́n tó bèrè question fún mọ̀ pé òjìnà lòlé. Má ṣàjẹ́ kí náà bí ẹ, ìyẹn ló lè dùn wá. So, now that you know this, we are going to solve questions. Let's now look at fuse rating. Fuse rating and circuit breaker. Fuse rating and circuit breaker. Fuse rating and circuit breaker. These are devices that prevent sudden inflow of electric charges. These are devices that prevent sudden inflow of electric charges. Sudden inflow of electric charges. I will talk about fuse. We have talked about circuit breaker before when we did magnetism. So, if you go to most of these electrical board, you are going to see some things there. Okay, I think it's also there too. That's all those red and green and all. I think that's what that one is serving as too. If there's a sudden discharge of currents and it can destroy things, that thing will go off. And by the time it goes off, when everything is calm, you can go and return it. Or like sometimes before, when electricity enters the house, you just spoil fridge, spoil TV, spoil everything suddenly. Have you ever experienced that? That sometimes electricity will just come into the house and boom, everything will spoil. So what they used to do is that they can put circuit breaker outside, so that if the sudden inflow is coming, that will just strip off, and it will help you to prevent many things from getting destroyed. Then another thing is this fuse. In that appliance, in that plug, if you open that plug, you are going to see something like it looks somewhat like this. Then there's a wire inside. It looks somewhat like this. So it will be with the plug. It will be with the plug. and it's usually connected to the live part, the live wire part. So the reason is that, let's say this is the live wire now. Then you have the neutral, you have, what's the last one? The hertz. Hertz is usually at the middle. So as electricity is coming, let's say this is the wire now, electricity is coming. If electricity will enter through live wire, then it will go back through neutral. So as the electricity is coming, if the current that is coming is too much, and it can destroy maybe your TV, and the fuse has it, the TV plug has a fuse in it, and the electricity is passing, let me put the fuse here, it will pass through the fuse. And when it passes through the fuse, if it's too much, this fuse will break. So that as it has broken now, you know it has disconnected it. So it will not be able to pass, get to the live and go on. Because if it is too much and it's able to enter, it can go and destroy things. So the fuse is there to help you cut the circuit so that you prevent excessive inflow of charges. I hope you are listening. So, I think I've experienced that too when I was very young. That I used to go to the, I just did not study Electic, but I like to be Oduro at times. Especially when things happen, I like to. It's just like these days now, just like the chair we want to make now. And each of these metals, you better go to school. I better be wise. Each of these metal, the person that wants to work said that the metal, one of them is 9,000. And I've learned something that most of these people that work, they just add money to. Well, adding money is not even my problem now. I said I want to do 60. You said I will need 120 pipes to do the 60. And I've always been doing that before. I've just probably send the money. I just said, okay, I checked all of those metals, then I realized that, okay, this is like 1 by 2. This is the one under there is 1 by 1. Then there's a part that we call flat bar. So this one that the wood is standing on is called flat bar. So I have this tape in my car. So I just came out, I measured it, and I knew that one pipe is always 18 feet. So I measured. When I measured the whole pipe, I realized that for that 1.5, I'm going to need 28 feet for 1.5. And I now multiplied times 60 that I want to use. Then I divided it by 18 feet. Because I know one pipe is 18 feet, and a chair we use 28 feet, and I want to make 60 chairs. So 28 times that number of chairs I want to make. And I know that each pipe is 18 feet. So when I divided, I realized that I'm going to be needing something like maybe 90 or whatever. 93.35. I shall approximated to 95. And each of these costs 9,000. So multiply 9,000 times 95. 855,000. Now, he now told me that we need 120. 120 times 9,000. That's how much? 1 0. So 1,080,000. Subtract this from this. So aside your workmanship, I will just dash you 225,000. And another thing is that metal is not even at the rate of 9,000. It's at the rate of 8,500. Be doing mark away. Yeah. Shebi, they are telling you to study now. You say no. Now imagine for the chairs you are sitting on. That's just one of the pipes. So there are 3 pipes there. This is just for one of the pipes. So now imagine that I cannot at least try my best to know about these things too. Until I now call him, I said, it's the total you will need. It's even 93, but I said, let's say 95, worst case scenario. Let's say the pipe is no longer up to 18, it's even 17 feet. Let's just say about maybe 95. I said, okay, no be like so, no be clinic on. Now so, if you're not ready to work, call me, I'll send you the money. If you are not ready, I'll go find someone else. He said, I will come see you, I'll come see you. So, I'll just go to the meter then. Our light will just go off. Then I noticed something. There's this fuse we used to plug there those days. I think it's in Primax now too. That's 3-phase that I can remove and plug. So when I removed it, I want a lot more. So that wire already cut. So I now went to look for copper wire. So I put another one back. Then I plugged it. In my mind, is something that is burning. Because I've experienced that countless time. So I'll now lose it. Then I'll now see this thing inside. That small fuse. But why you put it, that fuse is just 100 naira. I'll just go and buy it. I'll put it back. And the game will come on it. And that game then, I used to take it to Lagos, to Alaba, to go and fix it from Wayne. So now imagine because of ordinary fuse, mo wá gbé lọ Seko, and I'll call my guy, he will fix it and send it back for necessary. But tell me about it, ojú bọ̀ tán tí mi bá rí ṣe I can now call. The last one now, I think it was the printer. When the printer went over at the time, I just lost it and everything. Then when I was looking at the board, was a big capacitor to Joe, eléyìí Joe, fuse to Joe, iná ẹ̀ ó wọnú ẹ̀ gan. What's it mean? Okay, just pack it. I should be my capacitor to my soul there. So all of those things. And sometimes some people will even tell you that the board has spots. So please, all these things you are learning, sometimes it tells you. It tells you. Petrol is smelling. Eh? And it's because that's why there are different chargers. It's not every plug that has fuse. It's not every plug that has all these transformer-like components. There are different electronics in each of them, but some of it don't really have that power. That's why if you go and buy a charger, you can buy a particular charger at a very cheap price and another charger at a very high price because of the components in it. So there are some chargers that both cheap to plug it, boom, what's it Lord? Whereas there are some that you see that Google charger you put in your about power transmission. Abi, fuse. A fuse helps to prevent excessive flow of charges. A fuse helps to prevent excessive flow of charges that can destroy appliances. A fuse helps to prevent excessive flow of charges that can destroy appliances. A fuse helps to prevent excessive flow of charges that can destroy appliances. The fuse is always connected to the live wire. So don't forget that they can ask you. The fuse is always connected to the live wire. and it is made of a metal of low melting point. That's another question they can ask you. And it is made of, and I said a fuse is what? Connected to a live wire, and it is made of a metal of low melting point, such as lead, copper, and copper. Low melting point, full stop. A fuse is slightly rated. A fuse is slightly rated. A fuse is slightly rated above the normal current. Above the normal current. Slightly rated above the normal current the appliance can take. A fuse is slightly rated above the normal current the appliance can take. So what are we saying? In the fuse, let's say this is your TV. This is the wire. The wire has light. The wire has life, it has earth, and it has neutral. A fuse is connected to the life in such a way that when you plug it, as the electricity is coming from wherever it's coming from, the source, it will go through the life. Now, the wire that is inside this fuse, most times when you remove the fuse from your plug, you don't fix it, just straight away, go and buy another one, and maybe 100 naira or 200. It's my 1 year system. So, as the light is coming, you want to power your TV. As the light is coming, if this light is too much for the TV and can destroy the TV, it is the fuse that it will first destroy. Let's say that this TV, what can power this TV is 2 ampere. Just saying. Let's say what can power this TV is 2 ampere. This fuse is rated around 2.2. So to say, is rated around 2.2. The reason is that what can power this TV is 2 ampere. If I make the fuse 1.8, that means that anytime 1.8 pass, the fuse should cut. So please listen. Now, if I make it 1.8, what can power this guy? But if I make it 1.8, do you think anytime I plug, do you think this guy will ever come on? No. The fuse will always get destroyed. But if I make it around 2.2, that means I can always power this one. 2 can pass, Sabi. So if 2 pass, TV will come on. But anything above 2.2 that I know can destroy the TV, maybe around 3, around 4, what will happen to the fuse? Because it cannot take more than 2.2. So that statement I said that the fuse rating must be slightly above the rating of the what? The appliance. That's what I'm saying. If you make it below that of the appliance will not work. I hope you are picturing what I'm saying. If you make it too high, let's say I make the fuse rating like 5. IATBT by general, if you go on. Do you get my point? What can carry the TV is like 2. Then your own fuse rating is like 10. Then 7 word. So your fuse rating must just be slightly higher than the TV rating. Show you. And where did we put the fuse with the line? To bá fi sí neutral, ìgbà tó bá padà lọ ló ṣe máa cut bell àti wọlé tán. Do you understand what I'm explaining in a simple picture? So that is the thing I just explained there. Then the metal must have what? Low melting point. That's another statement I just mentioned. So pay attention. Now, what does that mean? Heat is equal to I square RT, abi? If the current is high, there will be more heat, abi? And now, as heat is being generated, what will happen to this wire? The wire we want the wire to cut if the current is too much. But if the wire can withstand high heat, that means it will take time for it to cut. But if it can withstand low heat, so as the heat is coming, being generated, and it knows that that current and the heat is generating is too high, it will cut. But imagine that it has high melting points. To cut. That's what it means by high melting point. I hope you are picturing all these statements. If it has high melting point, that means current can come and flow. I'm heat Sarah. Cut. But if it has low melting point at that rate, then immediately the current comes. What will happen? It will cut. It will melt immediately. And it will help you to disconnect the circuit. So that's what you have for that aspect. So please don't forget that, okay, the Muslims are going to mosque. They should stop class now. Okay. I wanted us to solve questions on all of these things before. But go and solve it for the sake of the Muslims. So go and solve it yourself at home. So please, the last thing you should learn at home, electrical power transmission. I've talked about it before. Electrical, question always come out here every year. Electrical power transmission. Wọ́n ti sọ pé tí máa ti rọra ń sọ̀kan fún ẹ gba ẹni kò tètè tẹ́tí ẹ̀ dáadáa. Gbogbo sórí tí mo sọ látàárọ̀ ìwọlé máa ń rí magnetism. So don't forget that. So later on ṣe àgbọ̀ àlè. What's this? So in a building like them, the board generates it, not an UTME. It's going to lead it. Magdalene, who is with you there? Victoria. Sheol is here. Why you people just call me by this time? The Muslims want to go to mosque. But you won't be able to have time to come again because you are starting your classes on Monday too. So please come and meet the ones that are around. Those that want to go to mosque can go, please. So Magdalene, come, and Victoria, Dr. Matthew. There is no class tomorrow, so we are going to Yes, what generates heat? So all of you can go. We'll see later.